Hi everybody, this is Tony E at Show IP Interface Brief, and today when I was on LinkedIn I saw a post of this topology which goes from a physical topology, this drawing, to a logical topology, and it said try to do it. This looked like a fun puzzle to solve, so I wanted to go ahead and give it a try. So I've done something like this before, so I just kind of wanted to talk about how you take something like this and transfer it like this. There are a couple of things. They're all very simple, basic networking fundamentals, but proper planning needs to be in order. In this drawing, for example, we want to go ahead and take router 1 and logically connect it to router 2, router 3, router 4, and router 6. So if this is our physical connection up here, that means this one switch port needs to be a trunk port, and it needs to have 1, 2, 3, 4 VLANs allowed across it. Well, what VLANs are we going to do? Well, that's where proper planning needs to come into order. I started mapping out in a blog post of exactly how I define these VLANs. It's a simple numbering scheme. For example, router 1 to router 6 is going to use VLAN 16. Router 1 to router 2 is going to use VLAN 12. Router 3, 13, and router 1 to 4 is 14. Okay, so I don't have the blog post completely written up. I'll quickly introduce you to it. Here's some planning steps, and here's how I mapped out the VLANs. And I sort of used this as my checklist to build the configs. On the left side of the screen here, I went ahead and started building the configs. I tried to do it as cleanly as possible so it could be neat, and tomorrow, maybe tomorrow morning, tomorrow night, I can understand what I did today. So I just went ahead and defined each VLAN. I did that sort of sloppily. I just did VLAN 1 through 100. It'll just create all of them. On each interface that directly connects to a router, I labeled it. I made sure the trunk encapsulation.1q was on, and I am only allowing the VLANs I need. A little bit sloppier way to do that would be to omit this statement, and it will just trunk all VLANs out to each router, and then the router's sub interface will determine which VLANs it will accept. All right, so I tried to do it a little bit neater, as well as I also have another config file here, which is every router's interface configs. It took me about an hour to type all this up. I hand jammed it all manually here for all 8 routers. After I did that, I went ahead and did some basic ping connectivity tests. After everything was reachable, then I put in the BGP configs. For BGP, because there weren't any restrictions, I did basic BGP. I think they call it classic BGP. I went ahead and made this autonomous system 1, 2, 3, 4 because it has routers 1, 2, 3, and 4 in it. And this is autonomous system 5, 6, 7, 8, obviously, because it has 5, 6, 7, and 8. We do 2 eBGP links, and everything is full mesh iBGP internally. So I went ahead and did that. I also defined a router ID for each one, a unique router ID value. Nothing about that here other than on each router I did redistribute connected. That's just so we could have end-to-end connectivity. And just to show what we have here, I have it in Eve. I have all my routers running. So for example, I'm going to try and do a ping for connectivity check from router 4 to router 8, and then we'll go ahead and do some trace routes just to verify that it's going through. Well, let's do a show IP interface brief. There's our interfaces, show IP BGP summary. Here's our 3 BGP peers, show IP route. Okay, you see we're learning the remote prefixes as well as some local prefixes from our area. And we're going to ping router 8. And let's do a trace route over to router 8. As you can see, it's going from my router number 4 up to router 1, to router 6, to router 7, and then to router 8. So there we have full connectivity. It was a fun lab. I'm starting to imagine all the other possibilities we can do with this lab. Thanks for watching.